Welcome to aminacademy.com. In electrical engineering, let us discuss about absolute and relative permeability. For example, a bar of a magnetic material, say iron, placed is a uniform field of strength H Newton per Weber. Suppose a flux density B Weber per meter squared is developed. That means field strength H Weber per Newton per Weber. The flux density B, that is flux density B is developed. B Weber per meter square is developed. What happened to that bar? Then here the rod become a magnetic field, magnet. Then absolute permeability of a material of the rod is defined as mu equal B over H. Then B equal mu H. Then absolute permeability, absolute B0 equal mu0 H. Relative R equal mu R H. Now, absolute permeability is the permeability of a free space. The relative permeability of a magnetic material is defined as the ratio of the absolute permeability. In this question, we will understand the concept of magnetic flux and magnetic field of lines. This question is related to concept of magnetism. Here, we have to define what is the field lines, magnetic field lines, how much it's go, what density it will spread like. Absolute permeability is the permeability of free space. We know that. The relative permeability of a magnetic material is defined as the ratio of the absolute permeability. Then complete step-by-step solution, we can define completely this. The measure of ability of a material to concentrate magnetic flux is called a permeability. That means it depends on the number of lines passes through particular cross-sectional area. Magnetic flux density is the measure of the number of magnetic lines of a force passing normally through per unit cross-sectional area. Magnetic field lines are imaginary representation of a to represent magnetic field. They also describe the direction of magnetic force. When there is a current flowing in a wire, a circular magnetic field is produced around the wire. A solenoid is long coil of a wire wound in the air that has been wound many times into tightly packed coil. This becomes a solenoid. Electromagnet uses electricity to create their power of magnetism. They can be switched on and off when the electricity is turned on and off. Powerful magnets are used high-speed bullet trains. These bullet trains run very efficiently because these trains will float over the track and reduces a large amount of friction. Soft iron is easily magnetized because it has a high permeability. Because of high permeability of the material, it can be easily magnetized and demagnetized. The permeability of any material is a measure of how easily for flux lines to pass through it. The permeability of a magnetic material varies according to the degree of their magnetization. The mathematical relation of the absolute and relative permeability is defined as, like here, K equal to relative permeability equal to permeability over absolute permeability. E0 is absolute permeability, E epsilon equal to absolute permeability, E0 is vacuum permeability, ER is the relative permeability. Therefore, K equal to ER, which is equal epsilon over epsilon 0. Remember this relation. Now we'll continue with some other definitions. Now, intensity of magnetization. Intensity of magnetization. Here, which is it can represent I. Here, it may be defined as the induced pole strength developed by unit area of the bar. Also, it is the magnetic moment developed per unit volume of the bar. Let it be, let M equal pole strength. Pole strength induced in the bar in Weber. A, phase or pole area. Phase or pole area in meter square. Then I equal M over A, that is Weber per meter square. Hence, it is seen the intensity of magnetization of a substance may be defined as the flux density produced in due to its own induced magnetism. Therefore, the formula for I we can tell like M over A equal M into L moments over A into L. That means you are multiplying up and down by L, the same factor. It becomes moments over volume. Magnetic moment per volume. Magnetic moment per volume. This is magnetic intensity. Next one, susceptibility. What is susceptibility? Susceptibility is defined as the ratio of intensity of magnetization I to the magnetic force H. Therefore, K equal I over H. That means intensity of magnetism over magnetic force. Now, relation between B, H, I and K. We relate all the definition here. B equal B0 plus M over A is equal to B0 plus I intensity. Now mu permeability is equal B over H, which is equal mu0 H plus intensity I over H, which is equal mu0 plus I by H. Therefore, mu equal mu0 plus K. Mu equal mu0 mu R. Therefore, which is equal mu0 mu R equal to mu0 plus K. Or we can say relative permeability is equal 1 plus K over mu0. These are the relations. For ferromagnetic and paramagnetic substances, K is the positive, and or diamagnetic substances, it is K is negative. For ferromagnetic substances like iron, nickel, cobalt and alloys, like nickel ion and cobalt ion, mu R is much greater than unity, whereas the paramagnetic substances like aluminium is slightly greater than unity. For diamagnetic material, for bismuth, mu R is lesser than 1. That means different types of magnets like para, ferro and ferromagnetic, the mu varies from more than unity or less than unity. So far we discussed about the relation between different definitions of magnets. Now in future videos we'll discuss about some solving problems regarding this concept. We have done. Please subscribe our YouTube channel.